one of my sub-projects, I'm developing an action game called Guilt and Glory. So let's quickly talk about what I think a proof of concept is. I'm sure you have at some point in your life done a proof of concept, whether it's for a product, a user interface, functionality, or feature. And I like to think of proof of concept as a throwaway piece of work. That means I build it without intending to evolve it to something that I'm going to end up using, for example. For me, this is very important because it eliminates any form of attachments. So when I build a proof of concept for a game, I'd like to have all the freedom, free of any shackles, flexibility, and also speed, and not having the constraints of, this code has to be maintainable or the solution must be properly structured. Essentially, the goal for a proof of concept is to prove only one thing, that the solution is best fit for whatever goal we set out to reach. Therefore, the goal must also be super focused, zeroing in only on one particular problem area. This is also very important because if the proof of concept is trying to tackle too many problems, there are too many variables for us to judge if the solution is best fit. Why do we want to do this? If we have multiple ideas that are competing in our head, the best way to decide is to test them out, especially when the problem is too complex to visualize or simulate in our head. A proof of concept is really the best playground for visualizing and simulating those complex problems and turn it into something that is simple, digestible, more manageable. How do we do this? First, for any proof of concept work, we need to define a clear motivation and a goal, just one motivation and just one goal. Also, pick a tool that we're more familiar with, something that will allow us to achieve our goal faster. Just because I use Unity and C# to build Guilt and Glory, it doesn't mean I have to use that same stack for my proof of concepts. So over the next few examples, you'll see that because I love the speed of JavaScript development, it sort of becomes my go-to language for building proof of concepts. You might ask, but if we use a different language, won't that be a waste of effort? Not really. First of all, let's remind ourselves again that a proof of concept at this point is a throwaway product. But more importantly, a proof of concept is all about the solution, not about how the solution is done. In some cases, you might be able to port across the core part of the codes that make up the solution into another language. But almost always, the most valuable thing that you can extract out of proof of concept is the pseudocode or the logic or the algorithm. That's why I tend to skip all the visuals. Make it ugly if I can, so that I don't necessarily become attached to anything from the proof of concept. So I've got 3 examples that I want to share, 3 examples of proof of concepts that I did in the past. This first one is UR related. The game provides you 6 characters or guilds to select from before you jump into the battle against the other 5. Initially, the guild selection was very basic and interesting. And then I received several feedback echoing that sentiment. I had the idea of placing and posing these characters in a circle formation surrounding the camera so that when the player goes left and right, the camera would rotate with it. But immediately I encountered problem with the camera going from one angle to another, especially when the player goes left or right repeatedly very quickly, when it becomes very jerky. So this proof of concept was really built to solve that exact specific problem. So let me show you what the final result, what it looks like, so that you can visualize what I was trying to achieve in my head. Alright, so that was the idea that I had in my head. So let's play around with the complete proof of concept here. On the right, you have this circle that pretty much simulates where the camera is supposed to be rotating all the time. And then the green dot there is the current position of the camera itself. And the red one is following my mouse cursor. And when I click it, it's supposed to be the target movement where the camera should be. So if I click this and the camera would move there, sort of interpolated in a smooth manner. But then what if it's like 180 degrees? If I go here a little bit, I know as a human being the shortest path would be on the clockwise side, like that. But if I go 180 degrees but left, a little bit to the left, the shortest path would be turning around anti-clockwise. Essentially, this proof of concept is really just to find the algorithm to be able to find the shortest rotation to the target. That's just to illustrate what the proof of concept essentially is like. It's as simple as that. Now, coming back to the actual game in Unity, you can see that in action, right? Essentially, you see the proverbial circle there where the camera is sort of like on a track As the player moves around really quickly left and right, it can determine which one is shortest rotation to go to. Yeah, so essentially, instead of having to play around with the game configurations or a lot of the codes that are not necessarily improving this kind of algorithm, you take it out to its own sandbox, you prove it, and then you bring it back into the game, and that proved to be a lot faster workflow. So the second proof of concept relates to the heads-up display that the player sees in the game. So for this one, I received several feedback in regards to difficulty some players were having with understanding how the minimap works. When you play the game, there's a minimap on the top right corner, but some players don't know where they are and the direction that they're facing relative to the battlefield. Some players want it to be still, some players want for the map to be automatically rotating relative to the battlefield. I decided to add some floating bubbles to indicate objects that are out of the viewport, essentially, or out of the camera view. This bubble indicates the relative position of any opposing guilds or objects that it can pick up that you cannot see through the camera or the viewport. So in this case, there's a potion on the left side, and as soon as it goes within the camera, then the bubble disappears. So this white rectangle on the right side is the game camera or the game viewport. Whatever you see within it, for example, is not indicated. So if I have an object there, it doesn't do anything. But as soon as the object moves out of the screen, then you see a floating bubble indicator there, as depicted by the circle. So if I go inside again, it disappears. If I go outside, then it... So essentially, with this algorithm, what I was hoping to achieve is create a script. You can attach it to an object, and the object automatically knows, okay, I'm outside of the camera, therefore I should have a floating bubble indicator. And for the last proof of concept, it's related to the core game mechanic. This is probably one of the most complex POC that I've done for the game, because to visualize it itself, it's fairly complex. So I'll try my best to explain it while we are in the proof of concept itself later on. But essentially, some players reported that the camera jumps abruptly, especially when the player kills some other units and consequently acquiring new units. And so you have some units here, and then you kill someone, some other units far away, and then those units become yours, and then the camera jumps. I'll show you why it happens later on. But this caused a lot of disorientation. So some players reported being disoriented playing the game because of this, which was not good. So the goal for this proof of concept, therefore, was to improve the stability of the camera movement. Camera is essentially looking at the center of mass. It was really about stabilizing the calculation of the center of mass. I'll also explain what the concept of center of mass is. So if I have a lot of units here, for example, I have 2, 3, 4, 5, 6, 7, 8. Let's say those are your army units. And that red cross there is the center of mass. So the center of mass is defined as a point representing the mean position of the matter in a body or system. So what that means is that if there are several points, the red cross representing the average position of all those unit positions combined. So traditionally, the center of mass is calculated using mean operation. That means you add together all these positions, x, y coordinates, and then you divide them by the number of units. So using mean can make this center of mass jump too far whenever there is an anomaly in those value distributions. If I acquire a new unit here, you can see the center of mass jumps from here to there. That's a significant jump. If I add 2, jumps further away, the camera doesn't know which cluster units to look at. So in this proof of concept, what I'm trying to see if changing the mean operation to median would actually stabilize the center of mass calculation. If the mean looks at the average of values, the median looks at the center of the distribution. So for example, in normal distribution, where the values are symmetrical, so the left and right is roughly similar, they don't show any difference. Both the mean and the median is pointing at the middle. However, when there are skews, where the majority of the values fall on one side over the other, you'll see that the average is skewed, or the mean is skewed. It's a little bit to the left. In this case, a little bit to the right. But the median remains in the center. The median is achieved by ordering the values from smallest to highest and then taking the value right in the middle, instead of summing them and then dividing the sum by the sample size. Let's look at what it looks like if we change this to mean. Let's say those are the units that we have, similar number roughly with the previous one. But then if I have an anomaly here, it's still stable, because essentially even if you put an anomaly, the middle of that value is still roughly there. Let's see, put in 2, 3, still unhinge, unhinge, unhinge. But then as soon as I add more, then it starts to move. Because essentially now the camera is saying, well, you have 3 clusters of army. I want to be able to show you all of them instead of just one. But if you only have one, the camera at this point says, don't care about that one. Even if it gets killed, you don't care about it. Because you do want to see, you want to focus more on this majority. So let's have a look at what that looks like in the game. We have this army, the center of mass is roughly there. As soon as that unit kills someone else, it acquired 2 units here, or 3. But the center of mass essentially is still there. That's why the camera is focusing on that area, rather than somewhere in the middle. And then keep going, and then as it attacks and acquire more units, you'll see that. It acquired new units, 3 of them, but still the center of mass is kind of stable. So there's less jumping around for the camera. If you pay attention to the camera movement, there's a little bit of interpolations in it with it as well, but essentially it doesn't jump too much because now it's using median rather than mean-based calculation. Here are some of the other cases where I've done proof of concepts in the past, trying to come up with cheap physics calculations because physics is very heavy. I'm trying to find alternatives to calculate the physics proof of concept for that. What about doing AI? That seems believable with emotion and memory deterioration and stuff like that, but still be able to calculate it cheaply, or separating assets from the game binary using addressable systems so that players can essentially not need to download the entire game binary again whenever there is any updates to the assets, for example. A couple of cases that I'm currently doing proof of concepts on: local multiplayer split screen to see whether it is really manageable, this kind of game, to be split in the middle and see whether 4 players, 2 players, 3 players sharing the same screen, whether it's going to be disorienting for them. Online multiplayer motion projection and interpolation, that's basically with the latency 200 milliseconds at least, and Nobian matchmaking system. Now that you've seen 3 examples, you can probably imagine how much it had essentially helped me in keeping my sanity with some of the math and logic challenges that I was going through. Really, these proof of concepts were like a teacher who showed me what a math problem looked like in real life instead of it being merely theoretical in my head. It definitely had helped me to prove things wrong quickly and consequently avoiding investing too much and wasting efforts on the wrong solutions. And to be honest, doing the proof of concept themselves is kind of fun for me, especially when I was feeling burnout or overwhelmed from constantly working on the game. These little POCs can serve as nice little rejuvenating distractions. And yeah, that's all I've got to share for today. Feel free to let me know if you have any questions, feedback, or share any thoughts. Thank you.